Hey everybody, welcome back to HIH Lessons. We're starting off today with Astronomy Year 1 Lesson 4. Again, like I've said in every other video, I am not a professor. I did not write any of this content, um, and I do not work for the website at all. I am just a student on the website, and I really, really enjoy um, this content. If you enjoy it, please give me a subscription and a like. Let me know if there's anything I can change. Let me know if there's any classes that you'd like me to start doing videos for uh, prior to finishing astronomy, and I'll see what I can do. In the meantime, let's get started with lesson 4, the AME quotient. Uh, the night seems a bit darker today as the moon cannot be seen against the backdrop of stars. As Professor Turing enters, he places two astronomy books on the table. The book on top is about the AME quotient, and the cover shows a picture of a woman in a hijab, excuse me if that's the wrong pronunciation of that, giving an astronomy presentation. Hello everyone and welcome back to astronomy class. I have noticed an improvement in everyone's telescope techniques, which is excellent. Just a few housekeeping announcements first. After the lecture next week, there will be a midterm. The midterm covers all material from the first 5 lessons. It is manageable for those who study, but will be challenging for those who do not. Midterms are never timed, but you will want to finish them in a reasonable amount of time. I do not mind spending the whole night proctoring the astronomy exams, but I am sure that a good number of you will want to go to bed at a reasonable hour. Let's begin our lesson. Again, this picture is gone. For whatever reason, it was again today's view of the moon from Flickr. If you look outside, the moon is not there. Where is it? Oh yes, I have seen many hands go up, which means many of you have remembered. Yes, the moon is in the waning crescent phase, which means that the moon is not visible at this time of day. When could you have seen the moon? If it were not cloudy, you could have seen the moon earlier today. Good job. I can tell that you have been paying attention and studying. If we are not sure what phase the moon is in today and had no access to lunar calendars, what magical device could we have used? Yes, that is correct. The lunoscope. Here's another question. Which of these pictures looks more like your view of the moon? Notice that I have covered up the lunar calendars in the room. Since you have seen the moon several times in the last few weeks, your gut answer is probably correct. How many say that the left image is more representative of what you see? The right image? The left image, according to this, is the image of the far side of the moon, while the right, the only one that we can actually see at the moment, is the image of the near side of the moon. The source from that is NASA. Good job. Yes, you are all correct. The right image of the moon is more representative of what you see. The right image is an image of the near side of the moon, and the left image is of the far side of the moon. Interestingly, the near side of the moon is the side that always faces Earth. No matter what phase the moon is in, the near side of the moon is always facing Earth, even though you cannot see a good portion of the moon due to its phase. Two phrases that describe the situation are tidal locking and synchronous rotation. Either phrase can be used in this class, and I will use both phrases interchangeably, which as both are used regularly in magical astronomical literature. In a future year, I will explain how gravity causes tidal locking. What you need to know for this class, however, is that tidal locking plays a major role in the moon's magical effects on the Earth. How is the near side of the moon different from the far side of the moon? From this picture, it is easy to see that the near side looks very different from the far side. In particular, the near side shows a very unique and complex relationship between light and dark designs. It makes the moon very identifiable. In fact, if someone had shown the picture of the near side to you in the quarter last week, many of you would correctly guess that is the moon. The far side, to many, may seem just like another moon or planet. The difference between the light and dark sections is critical to understanding how lunar magic works. The moon does not have a flat surface. Like the Earth, the moon has places of high elevation and places of low elevation, as well as flatlands and areas with more jagged profiles. Light portions of the moon's surface represent areas of higher elevation, also known as the highlands, and dark portions of the moon's surface represent flat, plain-like areas created by cooled lava from ancient volcanoes. These dark flat areas are called mare, or seas, based on a previous but incorrect assumption that these areas are lunar seas. Remember how I mentioned earlier that moonlight was actually reflected sunlight? The moon does not generate any light itself. All the light that you see coming from the moon is actually reflected from the sun. Some of the moonlight was originally earth light, or light from the sun that is reflected by the earth. Either way, all moonlight was originally sunlight. Of course, the highlands reflect more light than the mare because the highlands are much lighter than the mare. That being said, we as magical people know instinctively that moonlight does not have the same effects as sunlight, as we can see, for example, in werewolves. Werewolves maintain their human forms during the day and most nights. In their human forms, very few will realize that these people are werewolves. However, on the day of the full moon, they turn into their wolf-like beast forms, and they will act with the violence and attitudes you would expect of giant wolves. These observations seem to suggest that even though the moonlight is reflected sunlight, something about being reflected from the moon changes the light's magical properties. AME, the Astronomy Magical Effect Quotient. The term AME Quotient, or Astronomy-Based Magical Effect Quotient, describes the amount of magical effect a non-light-producing astronomical body has on another planet, or other object such as a moon or even a spacecraft. Unless the other planet is specified, the default planet is Earth. The concept of the AME quotient was first proposed and developed by Dr. Aisha S. Mansour, whom you will learn about in the last lesson of this year. She was one of the hometown heroes of Stamford, Connecticut's magical community. She had moved to the United States from England when she was 3 and spent most of her life in Stamford, Connecticut. She was also a foremother in my academic family tree. In other words, she mentored my mentors. She loved making up fun-sounding new terms for her many discoveries. The original name for the AME quotient was the Ame Quotient, but she changed it after realizing that other astronomers did not appreciate her sense of humor. Fun fact, she was an alumna of Hufflepuff House. Her mother, an Englishwoman, was the Hufflepuff head girl during her school days. One moment. The equation for the AME quotient is rather complex. However, I am not going to have you memorize the equation. All you need to know is the variables that constitute it. These factors are composition, what the astronomical object is made of; observed size, how big the astronomical object seems from Earth; albedo, how much light and magic the astronomical object reflects off its surface; teamwork, how the astronomical object interacts with other astronomical objects; surface, type and character of the astronomical object's surface. These factors, which Mansour cleverly arranged into the acronym COATS, C-O-A-T-S, will be defined in next week's lesson. For today, all you need to know is that objects that appear large from Earth and objects that have a high albedo value, that reflect a lot of light, tend to have a very strong effect on the Earth. In addition, the composition and the surface of the astronomical object can change the type and quality of the magic that impacts the Earth. Generally, astronomical objects that have a large magical effect on the Earth, such as the Moon, have a high AME quotient. Objects like undiscovered planets and star systems in other galaxies tend to have a low AME quotients because we rarely feel the effects of these planets on the Earth. The AME quotient is also why we learn so much about the surface and composition of planets in the solar system in Wizarding Astronomy classes. Yes, that information is fascinating, but that information can also help you make appropriate choices should you wish to take advantage of the planet's magic. Class is dismissed. Thank you for coming to class today. Feel free to stay to ask questions before the midterm, should you choose to do so. Alright, I'm going to upload one more video today, and that will be the AME in depth, the week 5. Again, please give me a subscription and a like if you like this video. Please leave me a comment on what you'd like to see next. I am doing this completely on my own time and of my own effort. and I'm putting quite a bit of work into this. So I would really, really appreciate your opinions on this. Again, this was Astronomy Lesson 4, or Year 1 Lesson 4 for the website Hogwarts is Here. Again, please ignore anything where it says Professor Turing. He is no longer part of this class. It's now Professor Gagarina. I believe that's how you say that. My apologies. Professor Penrose is temporarily assisting with this class as well. But again, please leave me a like and a subscription if you do like this video, or a dislike, of course, if you don't. Alright, thank you everybody, and I will see you in the next video.